Hi everyone, this is the final question on the November 2023 paper. So for anyone looking to maximize points or at least, secure some somewhat easy marks to obtain, this is where to start, okay? So when you start your reassessment, go to the last question first, okay? So in this part, you will investigate geometric patterns formed by squares of side 1 centimeter, interact with the stage control to see how the perimeter of the shape increases. Okay, so we have, in fact, let me find, so stage 1 here, which is 1 square, perimeter is 4 centimeters. Stage 2 has a perimeter of 12 centimeters. Stage 3 has a perimeter of 20 centimeters. And then we have stage 4, which is a perimeter of 28 centimeters. Okay, so show that the perimeter of the shape in stage 4 is 28. All you need to do here is, from the previous stages, you would calculate that 1 square, let's start that again. 1 square is equal to 1 centimeter. Okay, so each side of this square is 7 centimeters. Okay, so we have 4 times 7 centimeters, which of course is 28 centimeters. Okay, so that's part A done. On to part B. Write down the missing values in the table up to row 6. So here is plus 8, plus 8, plus 8. So my pattern is adding 8 each time. So the next one would be 36 and then 44. So again, that's 7B done. On to 7C, we have describing words to patterns in the table for the perimeter. So what you need to do here, the first thing you are going to state is the type of sequence. Okay, here, because it is going up by 8 each time, we know it is arithmetic. So it's an arithmetic sequence. So that's the first thing to say. The second thing you want to describe is what's actually happening. So okay, it's going up, but what's it going up by? Okay, so here you would write increases by 8 each stage. Okay, so far so good. Then the next question, so let me just come down. Oh no, I'll stay here. So 7D, write down in simplest form a general rule for P in terms of N. Okay, so because we know that it is increasing by 8 each time, we know it is something to do with the 8 times tables. So I am going to write down 8n. So P is equal to 8n. Okay, then what you're going to do on your scrap piece of paper is just note down next to your table values the 8 times table. Okay, so we would have 8, 16, 24, 32, 40, 48. And what you need to do is find the connection here. So how do you get from your 8 times table to the number to the left of it? Okay, so I can see, well, to get from 8 to 4, I need to take away 4. 16 to 12, subtract 4. 24 to 20 is subtract 4. And this works for every single stage, okay? So then I'm going to go back to my rule, which so far we have 8n, and I know that it is 8n subtract 4. Okay, on to the next question. So let's just fill in this table. So we know our rule P is equal to 8n subtract 4. Now it is asking me to verify my general rule, okay? If I see verify, it means use the stages that you calculated, okay? So verify use the n values that you calculated the answer for. Okay, so here we're going to use our rule, so P of 5, okay, and all I'm doing is substituting the number 5 in to my rule. So 8 multiplied by 5 subtract 4, that's going to be equal to 40 subtract 4, which is 36. I'm then going to tell the examiner this matches the value in the table. Okay, I'm going to repeat the process for 6 as well. So for stage 6, so P of 6 is equal to 8 multiplied by 6, subtract 4. So 48 take away 4 is 44. And you want to make the same statement that this matches the value in the table. And then as a final sentence, hence my rule is verified. If you hit all those 3 things, you will score at least 3 of the marks, okay? Depending on how much it's worth, okay? Here it's 3. Okay, so then, based on the previous geometric shape, another shape is also formed from squares of side 1 centimeter. You are going to investigate the area of the shape A formed in each stage. Interact with the stage control to see how the area of the shape increases. Okay, so so we've got stage 1 here, area is 5. Stage 2, the area is 13. Let's see, stage 3 is 29. Stage 4 is 53. Okay, show that the area of the shape in stage 4 is 53. Okay, so let's just think about the square first of all. Okay, so let me just highlight which bit I'm looking at first. So just this red square first, okay? I'm going to ignore those 4 bits that are stuck out currently. Okay, so I know that the side length of this square is 1, 2, 3, 4, 5, 6, 7. Okay, so it's a 7 by 7 square. So the first calculation I'm going to do is 7 times 7, which is 49 centimeters squared. But then, of course, I need to add 1, 2, 3, 4. Okay, so 4 needs to be added on, which is indeed 53 centimeters squared. Okay, just to elaborate a little bit more, these smaller squares, okay, because they are 1 by 1, okay, so 1 centimeter by 1 centimeter, they would have an area of 1 centimeter squared. Okay, so that's where the 4 comes from if you were unsure. Okay, so here we are on to our final question. 20 marks, this is the big one. Okay, so let's see what is happening. So area of the shape, okay, so we've got plus 8, plus 13. Okay, then we are adding 24. Oops, hold on, let me go back. That's not quite right, is it? Okay, plus 8, plus 16, sorry. And then we have plus 24. Okay, so then I went to look at my second difference because at the moment that's not the same, so it's not really helping me. Okay, I can see that the second difference is plus 8 and plus 8. Okay, so this is going to be a quadratic sequence. So let's continue the pattern. So the next value to add would be 32, then 40, and then because there's so much space in my table, you want to continue and complete that, okay? So plus 48, plus 56, plus 64, okay, and then plus 72. Okay, so we've got 53 plus 82. That would give me 85. Then 125. We've got 7, 8, 9, 10 here. Okay, 125 plus 48. That's going to give me 173. Okay, so 173. Then plus 56. So 239, 29, 229. And then we have plus 64. So 93. And then plus 72, 365. Okay, so put it more values and record these in the table. That's been done. Okay, next bullet point. Describe in words 2 patterns in the table for the area of the shape A. Okay, so 2 patterns. I'm just wondering, yeah, I've definitely cut this off, haven't I? Okay, let me just bring this back up. Sorry guys, I'm just looking at this here and I'm thinking that looks quite short for a 20-mark question. Okay, right, so describe in words 2 patterns in the table for the area of the shape. Okay, so I have to say 2 things. Well, the first thing, okay, this is a quadratic sequence, okay? Let me zoom in a bit. A quadratic sequence. Okay, so that's one thing. The next thing I could say is the second difference of the sequence is 8. Okay, that's 2 patterns. All right, so we can tick that off. We've done that one. Okay, write down in simplest form a general rule for A in terms of n. Okay, so remember, whatever your second difference is, you are going to half this. Okay, so A is equal to 4 because 4 is half of 8 and we know it's a quadratic, so I'm going to write n squared. Okay, then what I'm going to do, I'm just going to rub this out so it's nice and clear. I'm going to use this final column and I'm going to write my sequence for 4n squared. Okay, so when n is 1, 4n squared would be 4. When n is 2, 4n squared would be 16. Okay, when n is 3, then 4n squared would be 36. Okay, when n is 4, 4n squared would be 64. When n is 5, 4n squared would be 100. When n is 6, 6n squared, 6 squared times 4 would be 144. When n is 7, 7 squared multiplied by 4 would be 196. Okay, when n is 8, 8 squared multiplied by 4 is 256. When n is 9, 9 squared multiplied by 4 is 324. And then when n is 10, n squared, so 10 squared times 4 would be 400. Okay, so then I want to look at what the difference is here. Okay, so between these, well, here I have to add 1. Here I am subtracting 3. Here we are subtracting, let's see, 7. Then I'm subtracting 11. Okay, so if you look really carefully at the pattern here, and this is a hard one, okay, we're actually going down by 4 each time. Okay, so we're going 1, minus 3, minus 7, minus 11, minus 15. So this pattern here, okay, is minus 4, minus 4, minus 4, minus 4. Okay, so because of this, you are going to add minus 4n to your rule. Okay, so then let's see where that gets us to. Okay, so if I write out the sequence for that, I would have, so 4 lots of 1 is 4 minus n. So let's put this minus 4n, okay? So this would become 4 minus 4, which is 0. This would become 16 minus 8, which is 8. 36 minus 12, which is 24. Okay. Subtract 16, which will leave us with 48. Okay, here we would need to subtract 20, so it would be 80. Now, what I can see here, and again, guys, this is a really difficult one, but these values compared to these all have a difference of 5, okay? So we actually need to then add 5 on as well, okay? This is a tough one, okay? This is a full quadratic, all right? But this indicates that you are now finally at your full quadratic because we have an n squared, an n value, and a constant. Okay, so then we want to test and verify. So if at this point you've not managed to get a rule, or let's just say you've just got 4n squared, just go through the process of testing and verifying anyway to at least pick up some marks, okay? So make sure it's really clear in your notation what you're doing, okay? So for the testing, we are going to use the values given to us. So any two from the first 4. Okay, so a of 1 is equal to 4 lots of 1 squared, 4 times 1 squared, minus 4 times 1 plus 5. So this would be equal to 4 minus 4 plus 5, which is equal to 5. Okay, then you want to say matches value in the table. Okay, you're going to repeat this process with at least one other. So a lots of 2, a of 2 even. So 4 multiplied by 2 squared minus 4 multiplied by 2 plus 5. Okay, that gives me 4 times 4, which is 16. Subtract 8 plus 5, giving me a final answer of 13. Again, this matches the value in the table, and you want to say this. Your final statement to make at the end of the testing, hence my rule is tested. Okay, then you're going to go on to your verify, so verification. Okay, and this is where you use the values for the numbers that weren't given to you, so the ones that you predicted. So if you go back to the table here, these were the ones given to us, and then all of these are the numbers that we have predicted. Okay, so you can use any of those. So if I start with 5 and 6, so let me just get this right again. Okay, we've got a of 5. Okay, that's going to be equal to 4 times 5 squared minus 4 times 5 plus 5. Okay, so a of 5 is equal to 100. Subtract 20 plus 5, which is 85. Again, this matches, oh, don't want that. This matches the value in the table, or here actually, matches the values predicted in the table. Okay, and then we want to repeat this with a of 6. So 4 multiplied by 6 squared minus 4 multiplied by 6 plus 5. So 4 times 36 is 144. Subtract 24 plus 5 is going to leave us with a 125, which again, okay, that matches the values predicted in the table. Then, hence, my rule is verified. Okay. So then, if I go back again to my bullet points, we've done this bit. The only part left is this final answer. Okay, so it says justify your general rule for A in relation to the squares. Okay, so you want to go back to the previous rule, which was, where did we write that? This 8n minus 4. Okay, so we're going to copy that. Okay, actually. Okay, so the justification. Now, this is always the hardest part, okay? And if you can get all the way to this point, you've done really well and you've got a good chunk of marks already. Okay, so the justification, the proof is where we need to relate it back to what's happening. Okay, so this is all about the area of a shape. Okay, so it's asking us to justify your general rule for A in relation to the squares. Okay, so looking here and so on. Okay, so if we think about this bit here where we just calculated the area of the red square and then added on the rest, okay, we got to our final area. Okay, before that, when we were talking about just the squares, okay, we got a perimeter of 8n minus 4. Okay, so the thing I'm going to do first is recognize that the perimeter of a square, if I want to go from the perimeter to the area, I'm going to divide the perimeter by 4 to find out what one side is. Okay, so divide this by 4. So one side of the square in terms of n is equal to 2n minus 1. Okay, so if I think about a square here, okay, I've got 2n minus 1, 2n minus 1. So to find the area, I would multiply those two together. So 2n minus 1 times 2n minus 1. Okay, if I multiply this out, so I get 4n squared minus 2n, and then, oops, wrong one, minus 2n plus 1. Okay, that simplifies to 4n squared minus 4n plus 1. Okay, but we know those squares had these 4 additional on the side and it was the same for each. So because of those, I have to add on plus 4 for the 4 additional. Okay, so the area is equal to 4n squared minus 4n plus 1, which is what we found here. And then we need to add this additional 4, okay? When I simplify this now, my area is equal to 4n squared minus 4n plus 5. And then you want to say, oops, this matches my rule, hence my rule is justified. And there we have it. That's a really complex question for the standard paper. Well done if you've managed to get this far. If you only got up to the justification though, that is still a really good chunk of marks, okay? But definitely a complicated quadratic.